Hello, Algebra 1 students, and welcome back to your Semester 2 final review. We're looking at problem 44, which comes from lesson 9.3. It was a lesson on how to graph equations in intercept form. So they want to know which of the following functions is modeled by the graph to the right. All right. Well, there are a couple ways to do this. I'm going to start with each of the equations, though, and just kind of work through and remind you of how to work with intercept form. Right? These equations are all modeling a times x minus p times x minus q, where a, of course, is going to control the steepness of our graph and can give us 2 points from the vertex, and these two are going to really help us quickly find the x-intercepts. Okay. Speaking of, since it looks like all of these have different x-intercepts, I bet we can quickly use them to figure out what our x-intercepts are. Now, peering at the x-intercepts over here, I see an x-intercept of 2 and an x-intercept of -4. So I'm going to focus in on the two guys that have x-intercepts of 2 and -4. I know it's immediately not going to be these. 1 and 9 have nothing to do with these x-intercepts. They're trying to trick you and see that the vertex is -1, -9. We can't see the vertex from intercept form. It's not HK form, right? And you'll have a formula like this on your test. You'll be able to see that these are H and K. But we're down to C and D pretty quickly. Okay, so what we're going to do is we're going to say, okay, let's take a look at C, because it looks like 2, -4. C makes sense. So I'm going to start with y equals x plus 2 times x minus 4 and say, all right, let's get these x-intercepts. To get x-intercepts, we always replace the y with 0. And the reason, no pun intended, why we do that is because our first point here is 2, 0, and this point is -4, 0. Can you see that the y's for our x-intercepts are always 0? So we need to replace the y with 0. Not sure how my 4 became a y. Awkward. And then, from here, we have to solve. Now, if you have two different x's in a problem that you can't really combine together, we can't do SADMAP right away. There's got to be something else. And your something else has a couple other options, sometimes quadratic formula, sometimes completing the square. But that's only if our equation's in standard form, and this one's not, so those are out. What else do we have? Oh, right, the zero product property. The zero product property. Which is a fancy name that you don't need to have memorized, and all it really tells us is that we need to take each of these factors, this is already in factored form, and create smaller equations because we are equal to 0. So we're going to take x plus 2 and set it equal to 0, and x minus 4 and set the other factor equal to 0. Now, each of our smaller equations only has a single x, and so to go through and isolate, we can just undo what's attached to x by following SADMAP. Subtracting 2 from each side gives us x equals -2, and adding 4 to each side gives us x equals 4. If we look at that, do those x-intercepts match? Well, no, x equals 4 is over here, x equals -2 is over there. So this tells us that C is also out. I'm pretty confident it's D. Now, to prove that it's D, I'm really going to do a whole bunch of work, not a whole bunch, but a little bit of extra work, just to remind you of how we find all the pieces of this parabola in case this problem's a little bit harder on your test. So x minus 2 times x plus 4. Remember that. Y equals x minus 2 times x plus 4. And let's go ahead and start with the x-intercepts. That probably makes the most sense since that's what we just did. And I'll label my work too. The x-intercepts, 0 equals x minus 2 times x plus 4. We know we make those two equations, x minus 2 equals 0, or x plus 4 equals 0. And as mentioned before, add your 2 to each side. That one matches, x equals 2, excellent. And our other one, we subtract 4, and we end up with x equals -4. Whew! X-intercepts are matching. Good so far. I'm not too much of a fraud. Let's go ahead and find that y-intercept. The y-intercept is found by pretty much doing the opposite of the x-intercepts, right? This y-intercept we can see down here is 0, -8. Looks like they made the x 0. So let's try that. y equals 0 minus 2 times 0 plus 4. Y is already isolated over here, so it's not a sad map issue. This is just PEMDAS, so do what's in the parentheses first. That was pretty easy. And then the only thing left to do is multiply, and we find that y equals negative 8, which does match up. Whew! What about that vertex down there, that negative 1 comma negative 9? Well, we should remember for the vertex that our vertex always occurs exactly in between my two x-intercepts. So let's zoom in on those x-intercepts and see if we can figure out what's exactly in between. I'll go 1 in each direction, 2, 3, ha! Looks like exactly in between is negative 1. So we can go back here and we can say the h value of our vertex, if our vertex is in hk, the h value has to be negative 1. That's just found by looking at the graph, or you can just count and see what's in between 2 and negative 4. Or if you really wanted to, you could take 2 plus negative 4, add them together, and divide by 2. Negative 2 divided by 2 is negative 1. Regardless of how you do it, your vertex has an h value of negative 1. And then how do we find the k whenever we have the h of the vertex? Well, that goes back to our original equation. So our k value is going to be found by using the original equation, but replacing the x's with the h that we found. I'm just leaving it blank so I can color code it. Negative 1, negative 1. So then from here, we follow PEMDAS once again. Negative 3 times positive 3, which gives us negative 9. And so our vertex is negative 1, negative 9, which indeed does match the graph up above. Now again, if this was a multiple choice question, which it is, and you were pressed for time, which you might be, you only get 2 minutes per question on your final, you should be able to quickly look and say, oh, this is negative 4, this is positive 2, that's the only one that matches. But if they gave you other ones, and let's say maybe they even took it a step further and they put different numbers in front, like a 1 and then a 2 and then a negative 1 and then a 4, but all the x-intercepts are the same, we should also know what to do with the a values, right? Where in this case my a value is 1. Well, that tells me if we look at our vertex, which is negative 1, negative 9, I am allowed to go up 1 and over 1 time in each direction, and I should stay on my parabola. And if we look from the vertex, if you go up 1 over 1, we certainly get a point, the y-intercept. Up 1, left 1, we also get a point here. So it looks like the a value also matches up to our graph. So thanks for tuning in to a quick reminder of how to graph this intercept form. And if you want a more in-depth explanation, Lesson 9.3 does a much better job of explaining it. Keep finding success on that review so you can be successful on a pretty tough final. Appreciate you guys tuning in.